Hello and welcome. In this video, we're going to take a look at how we can add passwordless register to ASP.NET Core 8 Identity using FIDO2. Now I have an existing solution with a web application project. This project has our application DB context, it has our application user class, and it also has our FIDO2 related entities. We've also got migrations for the database like so. I've also got an areas directory with our view start file within the identity area. And then we've also got the standard pages in a Razor Pages project. Next up, inside our program startup, we're adding in our application DB context. We're then adding in identity with our custom application user class. And then we're adding in Razor Pages. And then at the bottom, we're adding all of our middleware into the request pipeline. So the first thing that we are going to want to do in order to get started is we're going to want to add in the FIDO2 development app settings. So inside our app settings.development.json, I'm going to create a new section in here called FIDO2. And within here, we're going to create a few app settings related to FIDO2. So the first setting we're going to want is a setting called origins. This is going to be a list of origins that our web application will be running on. So for the purposes of this sample, I'm going to use the local host address, and that's running on port 7078 on HTTPS as the scheme. Next up, we're going to want a setting called server domain, like so. And this is going to be the domain of the server that is hosting our web application, which for this sample will just be localhost. And then the next setting we're going to want is the server name setting. And this is basically the friendly name, the human readable name of the server. For the purposes of this sample, I'm just going to, again, call it localhost, but you can call this whatever your website name could be, for example. Last but not least, we're going to create a setting called timestamp drift tolerance, like so. And this is basically the leeway that we have between different clocks on different devices. So when the user sets up a public key credential on their device, it may well have a slightly different system time. The clocks might not quite be in sync between, for example, their authenticator device and our backend server. So this timestamp drift tolerance basically allows for a little bit of leeway between potentially out of sync clocks on different devices. And for this, we're just going to give it the value there of 300,000, like so. Again, feel free to adjust any of those settings to meet your preferences. So now that we've added the FIDO2 app settings into our app settings.development.json, we're now going to add the FIDO2 related services into the startup of our application. So within the program.c# file, we are going to want to add in the FIDO2 services. So what we're going to do is we're going to say builder.services, like so, and then we're going to say add FIDO2. And this is going to take an options action, and like so. And within here, we're going to customize the options for FIDO2. So the first thing that we're going to do is we're going to say options.origins equals builder.configuration.getSection, and this is going to be FIDO2:origins, and then we're going to say .get, like so, and the type of this is going to be a hash set of type string, like so. Next up, we can say options.serverDomain, and this is going to be builder.configuration, and this is going to read in the FIDO2 server domain app setting. We're then going to do the same thing for the server name, like so. And then last but not least, we're going to set the timestamp drift tolerance. And this is going to be builder.configuration.getValue, and it's going to be of type int. It's an integer value. And this is going to be FIDO2 and then timestamp drift tolerance. And that basically sets up the FIDO2 options in our application from the settings that we defined in the appsettings.development.json file. Now, the next thing that we're going to do is add session-related services and middleware into our application, and I'll highlight where those are used a little bit later on in the video. So what we're going to do is we're going to say builder.services.add session, like so. And then we're going to want to customize the options for the session. And we're going to say options.cookie.http only equals true. And we're then going to say options.cookie.samesite, and that's going to be samesite-mode.strict in order to help protect the cookie that's used for the session. The other thing that we're going to want to add is a distributed cache implementation in order for the session functionality to work as intended. Now, for the purposes of this sample, I'm simply going to use the distributed memory cache. However, in your actual application, you may wish to use an alternative distributed cache implementation, such as Redis, for example. But to keep things simple, for the purposes of this sample, I'm just going to say builder.services.add distributed memory cache, like so, in order to add the distributed memory cache implementation into the dependency injection container. Next up, we're going to want to add in the session middleware. So if we scroll down towards the bottom, and then where we have our call to app.use authorization and app.map razor pages, within here we're going to want to say app.use session. And it's important to get the ordering of the middleware correct to ensure that they execute in the intended and correct order. So we add that session middleware in between the call to use authorization and the call to map razor pages. So now that the FIDO2 service has been set up and its dependencies have also been set up, we're now going to add a FIDO2 handler into our web application. So what I'm going to do is I'm going to add a new directory and I'm going to call it handlers. And within here, I'm going to add a new class and I'm going to call it FIDO2 Handler, like so. I'm going to make this a static class. And then we're going to, within this class, implement two handler methods. So the first method that we're going to implement is a method that will be used to create attestation options. Those are the options that are used in order to create an attestation when the user registers. And then the second method is actually going to create the attestation itself and store it in our database. So the first method that we are going to want to implement is the create attestation options method. And this is going to take an input model from the request body. And so first of all, we're going to create that input model. So what we're going to do is we're going to create a public class in here. And I'm going to call this public class create attestation options input model, like so. And the first property that we're going to want in this class is a public required string called a username with a getter and setter, like so. Next up, we're going to want a public string called attestation type, again with a getter and setter, and this will have a default value of none. We're then going to create a property for the authenticator attachment. So we'll do that like so. This will be a nullable or optional property, and we can call that authenticator attachment. We're then going to create another property called resident key, and this will be of type resident key requirement. Again, have the getter and setter there, and this is going to default to a resident key requirement of discouraged. And then last but not least, we're going to create a property for the user verification requirement, and this is going to have a default value of user verification requirement dot preferred. So this is the input model that we will be expecting in the request to create attestation options. And what we're going to do now is create the actual method implementation to create our attestation options. So what I'm going to do is create a static method in here like so. It's going to return OK, and this is going to be of type credential create options from the FIDO2.net library. This method is going to be called create attestation options, like so. And this is going to take a few different parameters. The first one is FIDO2, like so. And this is the FIDO2 service that we registered in our application services earlier on in the video. Next up, we're going to want the HTTP context, like so. And then last but not least, from the request body, we're going to want to inject in there our input model, like so. So those are the three parameters that we want for our create attestation options method inside our FIDO2 handler. And now we're going to start work on actually implementing this method. So the first thing that we're going to want to do is create a FIDO2 user instance. So what we're going to do is we're going to say var user equals new FIDO2 user, like so. And the FIDO2 user is going to have a name, and this is going to be input.username, like so. We're then going to create an identifier for our user, and in order to do so, we're going to say GUID.newGUID, and then we will convert that to a byte array, like so. And then we're also going to use the username from the input as the display name for the user. If I just pop those couple of lines back in like so. And then next up, we're going to want to create an authenticator selection instance. So what we can do is we can say var authenticator selection equals new authenticator selection, like so. And then within here, we're going to want to set the authenticator attachment to that from our input. We're then going to set the resident key again to the input.resident key. And then last but not least, we have the user verification, which we will again set from our input model. Next up, we're going to want to create our attestation preference variable. So we can say var attestation preference, and then this is going to be input.attestation type, and then we're going to use one of the helper methods inside the FIDO2.net library to enum, and this is going to be converted to an attestation conveyance preference enum, like so. Next up, we're going to want to create a variable to store the extensions for the authenticator. So what we're going to do is we're going to say var extensions equals new authentication extensions client inputs, like so. And then within this class, we're going to want to set the extensions property to true. we're going to set the user verification method to true. We're also going to set the device pub key property to a new authentication extensions device public key inputs, like so. And then inside here, we're going to set the attestation property to input.attestation type, like so. And then last but not least, we're going to set cred props to true, like so. So now that we have our extensions there, we're going to want to create the options for the attestation. So what we're going to do is we're going to say var options equals, and then we're going to say FIDO2 dot, and then we're going to say request new credential, and this will return our credential create options object. And within here, we're then going to pass in the variables that we have just created. So we're going to pass in the user as the first parameter. Now the second parameter is a list of credentials to exclude. Now because we're going to be calling this method from the register page, the user won't exist yet, and so they won't have any existing credentials that we want to exclude. Now, the exclude credentials can be used to disallow particular credentials, for example, those that the user may have already created previously, if they are going on to create maybe second, third, fourth, etc. Public key credentials. However, because the user is registering for the first time and they don't have any existing credentials, we can simply set this to a new list of public key credential descriptors, like so. We're then going to want our authenticator selection, and then our attestation preference, and then last but not least, we can pass in our extensions like so. Now what we're going to want to do is we're going to want to store those options in the session for the current HTTP context. And that's because we will need to retrieve these options when we actually create the attestation itself later on in the next request. So this method just creates the options, and then we need to retrieve the options when we come to actually create the credential itself. So what we're going to do is we're going to say HTTP context.session, and then we're going to set string, and this is going to be called FIDO2 attestation options. But again, feel free to call that string whatever you like, depending on your conventions or requirements. And then what we're going to do is we're going to say options.toJSON like so, in order to store the options object as a JSON string within the session for the HTTP context. Last but not least, we're then going to return typed results dot OK, and then we're going to return those options in the response to the request. So this is the method to create the attestation options. And now what we're going to do is we're going to implement the method that actually creates the credential itself, using, amongst other things, the options that we've created within this method. So what we're going to do, back up at the top of our FIDO2 Handler class, we're going to create another public static method. This one is going to be asynchronous. It's going to return a task of type results. And within here, we're going to specify the different type of results that we can return. And that's going to be either a bad request, or it's going to be a typed OK result. And the type here is going to be registered public key credential, like so. We're going to call this method create attestation. And then what we're going to do is we're going to, much like we did before, fill in the parameters to be injected within this handler method. So the first thing that we're going to want is from body, and this is going to be our authenticator attestation raw response. And I'm simply going to call this attestation response. And this will be the response that the client generates using the web authentication specification. That attestation response then gets passed from the client in JavaScript into this handler in our backend server side, and we then use this attestation response along with those options that we previously created in order to create the credential and store it in the database. So the next parameter we're going to want is the FIDO2 parameter. We're also going to want the HTTP context, like so. And then we're going to want to inject the sign-in manager of type application user, like so. And then we're also going to want the user manager, again of type application user. We can simply call that user manager. And then because this is an asynchronous method, last but not least, we're going to inject a cancellation token using the default value there in case one is not provided. So what we can now do is start work on implementing this method in order to actually create the attestation itself. So the first thing that we're going to want to do is retrieve the previously stored options from the session. So what we're going to do is we're going to say var JSON equals http context.session, and then we're going to get string, and this is going to be the same key that we used previously, which is FIDO2 attestation options. Again, if you called the key something different within the create attestation options method, then make sure that both of the keys match up. There needs to be the same key in order to both set and get the string from the session. What we're then going to do is we're going to do a check to see if JSON is either null or empty. And if it is null or empty, then we're going to assume that the user has not yet created the attestation options, and therefore we're going to return a bad request because the user will have needed to create the attestation options before we can actually create the attestation itself. So what we're going to want to do here is simply return typed results.bad request. Now, provided that the JSON is not either null or empty, we can say var options equals credential create options, and then we can say dot from JSON, passing in that JSON string, and this will give us our credential create options instance that we stored earlier on within the session. So what we can now do is we can actually make the public key credential. So what we're going to do is we're going to say var credential result, like so, equals await FIDO2 dot, and then we're going to say make new credential async, like so. And what we're going to do is we're going to pass in the attestation response that we received from the request body. We're then going to pass in the options that we previously stored in the session. And we're then going to define an async function in order to determine whether or not the credential is unique to the particular user. So what we're going to do is we're going to create this function here with the first parameter being params, and the second parameter here being a cancellation token, like so. And this is going to be an asynchronous function. And what we're going to do within here is we're going to check to see if the credential being created is unique or not. And that's because we want to make sure that we aren't storing potentially duplicate credentials for different users. So for the requirements of our application, of our sample implementation, we're going to ensure that each credential can only be stored for a single user, and it can't be shared between multiple users. And that's what this callback function allows us to do. It allows us to check to see if the credential is unique to a user. So what we're going to do in here is we're going to say await, and then we're going to say user manager dot users, And then we're going to say select many. And then within here, we're going to say user.public key credentials in order to select all of the public key credentials for all users. And then what we're going to do is we're going to say all async. And then we're going to specify the condition where the credential ID is not equal to params.credential ID. And then we can also provide the cancellation token to the all async. And that check will essentially iterate through all of the public key credentials to ensure that none of them have the same ID as the credential ID that we are creating. So this means that we will not have any duplicate credentials. In other words, the same credential being used for multiple different users. It ensures that each credential will only exist once and is unique amongst all users. Again, if you've got different requirements for your application, then feel free to adjust the logic within this function for your particular requirements. And last but not least, we're going to pass the cancellation token into the make new credential async. So now that we have that credential result, we're going to want to first of all make sure that the credential was made successfully. So in order to do this, what we're going to do is we're going to do an if check, and we're going to say if credential result dot result is null, then what we're going to do is we're going to throw a new exception, and then we can take the error message from the credential result. In other words, if we don't have a credential as the result, then we will assume that an error has occurred, and then we will throw an exception with the error message from the make new credential operation. However, if we do have a result, in other words, if the credential was created successfully, then we can now look at storing it in the database. So what we're going to do is we're going to say var credential, and then we're going to create a new instance of the public key credential type. And what we're going to do is we're going to create this public key credential based on the credential result that we got from the FIDO2 service. So first of all, we're going to set the ID, and for this we can say credential result.result.id, like so. Next up, we're going to set the public key, and this will be credential result.result.public key. We're then going to set the signature counter, and this will be set to the sign count property of the credential result. We're then going to specify whether or not the credential is eligible for backup, and we can also specify whether or not the credential has actually been backed up. Next up, we can do the same thing for the attestation object, again using the attestation object in the credential result. And we're going to want to do the same thing for the client data JSON, like so. We can also set the attestation format, once again, much like everything else, using the credential result. And we're also going to specify the AA GUID from the credential result as well. And then last but not least, we're going to populate the user ID, and we're going to use a GUID for our user ID. So what we're going to do is we're going to create a new GUID, and we're going to use the user object within the credential result. We're going to get the identifier for the user, and then we're going to convert that GUID into a string. So there we have our public key credential entity ready to be added into the database. Next up, we're going to work on the relational entities. So the first thing that we're going to do is we're going to add the authenticator transports. So what we're going to do is we're going to say for each, and we're going to say a credential result.result.transports, like so. And this will be var authenticator transport. And then we can use our public key credential entity to say credential.authenticator_transports.add, and then we're going to add in a new authenticator transport, like so. And this is going to have the public key credential ID from our credential result, like so. And then the value of the authenticator transport is going to be the authenticator transport that we are iterating over from the transports array in the credential result object. Next up, we're going to populate the device public keys if one has been specified. So what we're going to do is we're going to say if credential result.device public key is not null, then we're going to say credential.device public keys.add, and then we're going to say new device public key, like so. And we're going to say public key credential ID equals credential result.result.id, much like we did for our authenticator transport. And then we're going to specify the value is credential result.result.device public key, like so. So this sets up the authenticator transports and device public keys for our public key credential entity. And last but not least, we're going to now create the actual user object that we're going to then store in the database. So what we're going to do is we're going to say var user equals new application user, like so. And then within here, we're going to say ID equals, and then this is going to be the identifier for the user taken from the credential result. So what we're going to do is we're going to say new GUID, and then we're going to pass in the byte array from the user identifier for the credential result, and then we will convert it into a string to match the type of the ID property in the application user class. Next up, we're going to then say a username, and this is going to be taken from the credential result.user.name. And then last but not least, we can specify our public key credentials will have the credential that we have just created added to it. So what we've got there is we've got our initial credential entity. We've then gone through and added in the authenticator transports. We've added in the device public key if it's been provided. And then we've created an application user with an ID, a username, and also the credential inserted into the list of that user's public key credentials. So what we can now do is use that user variable to create the user via the user manager. So what we're going to do is we're going to say var identity result equals await user manager dot create async, and we're going to pass in our user. Notice that because we are using FIDO2 and this register is passwordless, we don't specify a password as the second parameter for the create async method. We simply just pass in the user without a password. Next up, we're going to check to see if the identity result is successful. If the identity result did not succeed, then we're going to throw a new exception, and then we're going to stringify the identity result, like so. However, if the identity result was successful, then we are going to go ahead and sign in the user. So what we're going to do is we're going to say await sign in manager dot sign in async, and then we're going to pass in the user, and we're going to specify that the sign-in is not persistent. However, depending on your requirements, you may wish to set that to true if you want the user to remain signed in after they've closed the browser. For the purposes of this sample, I'm going to leave that as false, but feel free to update that based on your particular requirements. Last but not least, I'm going to return a typed results dot OK, And then I'm going to pass in the credential result like so. And this means that we're then going to return that credential result back to the client in order to indicate that the attestation has been created successfully and the user has been signed in. So that is the implementation for the various different methods in the FIDO2 handler. As I say, we've got one method in there to create the attestation options that are then used to create the attestation itself. So what will happen is the client will request the attestation options from the backend. The backend will then return those options back to the client. The client will then display a UI prompting the user to create a public key credential via the browser. And once that's done, the result of that operation is then passed into the create attestation method within this FIDO2 handler. And we then use that result to create a public key credential and then store that public key credential along with the registered user inside the database using the user manager. And then last but not least, if that has all happened successfully, we then sign the user in to the application. So now what we're going to do is we're going to map these two endpoints inside our program.c# file. So what we're going to do is come into program.c# like so. And just beneath the app.mapRaiser pages, I'm going to say app.mapPost. And I'm going to specify / FIDO2 / create attestation, like so. And then I'm going to say FIDO2 Handler dot create attestation. And then I will copy that now and do the exact same thing for creating the attestation options. And we just name that like so. So we've got two endpoints there, two post endpoints, one to create our attestation and the other to create our attestation options. And so now what we're going to do is we're going to take a look at the client-side JavaScript code in order to handle the client-side logic for the passwordless register. So what we are going to do inside the www root folder, within this JavaScript folder, I'm going to create a new JavaScript file, and I'm going to call this file helpers, like so. And the FIDO2.net GitHub repository helpfully includes a couple of helper functions that we use in JavaScript in order to coerce the JavaScript variables to array buffers and to base64 URLs. So what I am going to do is I'm just going to copy those two helper functions as is directly from the FIDO2.net repository. And those two functions are coerce to array buffer and coerce to base64 URL. And we're going to be making use of those within our FIDO2 logic within the register script. So what we're going to do now is actually go on ahead and create that register script. So we're going to right click on the JS folder. We're going to create another JavaScript file, and I'm going to call this file register. So we're going to have a file here called register.js. And what we're going to do here is implement the client-side JavaScript logic to create the public key credential. So what we're going to do is we're going to say a document dot get element by ID, like so. And this is going to be register form. And then what we're going to do on that element is we're going to add an event listener, like so. This is going to be a submit event listener. And this is going to call an asynchronous callback function in order to handle the register form being submitted. So what we do is we will create that asynchronous function like so. And the first thing that we're going to want to do is we're going to want to prevent the default submit functionality by calling event.preventDefault. And now that we've done that, we can now implement our custom form submission logic. So the first thing that we're going to want to do is get the form data from the register form. So in order to do that, we are going to say const username, comma, return URL, like so. And we will then say equals object dot from entries. And then we're going to say new form data. And then we're going to pass in the target of the event, which is our form in this case, into the form data. And this is going to give us the username and the return URL values from the submitted form. Next up, we're going to want to send a post request in order to create the attestation options. So what we're going to do is we're going to say let response equals, and we're going to say await fetch, and then we're going to say /FIDO2 / create attestation options, like so. And then within the init options for the fetch, we're going to say body, and then we're going to say JSON.stringify, and we're going to stringify an object that contains the username. We're going to leave all of the other options there as their default values to be populated by the defaults within the input model that we defined earlier on in the create attestation options endpoint within the FIDO2 Handler class. Next up, we're going to specify the headers, and this is going to be content type, application JSON, like so. And then last but not least, we're going to specify that this is a post request. Then we're going to do a check to see if the response is okay or not. If the response is not okay, then we're going to throw a new error, and we're going to say failed to create the attestation options, like so. If the response is successful, in other words, it's a 200 response from the backend server, then we can say const public key equals await response dot JSON, like so, in order to deserialize that JSON response into a variable. And then we're going to want to convert the JSON object that we get back there into a browser compatible format. And this is where those helper functions that have been provided by the FIDO2.NET library come in handy. So what we're going to do is we're going to say public key dot challenge equals, and then we're going to say coerce to array buffer, and we're going to pass in the public key dot challenge. And this is going to convert that public key challenge into an array buffer, which is what the browser is expecting when it's prompting the user to create an attestation. As I say, these helpers are used to essentially convert from the deserialized response into a browser compatible format. So next up, we can say public key dot user dot ID, and this is going to once again equal a coerce to array buffer, and we're going to pass in that public key dot user dot ID. Then we're going to say for const exclude credential of a public key dot exclude credentials, we're going to say exclude credential dot ID equals a coerce to array buffer, and then we're going to say again exclude credential dot ID, converting that identifier into an array buffer. Next up, we're going to say if a public key dot authenticator selection dot authenticator attachment equals null, then we're going to convert that from null to undefined. So then we say public key dot authenticator dot selection dot authenticator attachment equals undefined, like so. Next up, we're going to pass that public key into the credentials.create function in order to actually create the public key credential. So what we're going to then say is const credential equals, and then we're going to await navigator dot credentials, and then we're going to want to create a credential, and we're going to pass in the public key within the credential creation options, like so. This is then going to prompt the browser to open up a UI for the user to then create a public key credential. And so what we're going to do once we have that credential is we're going to then send it to our backend server-side create attestation endpoint in order to then persist that credential and store it in the database alongside the registered user. So what we will do here is we're going to say response equals await fetch, and this is going to be / FIDO2 / create attestation, like so. And then the options for the fetch are going to be as follows. So we're going to specify the body is going to be a JSON.stringify. This is going to be an object, and within this object, we're going to specify the credential ID. We're also going to specify the raw ID of the credential. However, what we're going to do is we're going to coerce this to a base64 URL. So previously we were converting from the backend server-side format into a front-end client-side format, and now we're going to do the inverse of that. So we're going to be converting from the client-side browser format into the format that is recognizable from the backend server side. So in order to do that, we're going to coerce that raw ID to a base64 URL. And then we're going to specify the credential type, like so. We're then going to specify the extensions of the credential. And to do that, we're going to call the credential.getClientExtensionResults method, like so. And then we're going to want to create a response object. And within the response object, we're going to have the attestation object, like so. And we're going to want to coerce this to a base64 URL. And this will be credential.response.attestation object. We're then going to specify the client data JSON property. And once again, this is going to be coerced to a base64 URL. And this is going to be coming from the credential.response.clientDataJSON. And then last but not least, within this response, we're going to specify the transports. And to do that, we can simply specify credential.response.getTransports, like so. So what we can then do, now that we have our body, is we can then specify the content type application JSON header. And then we can specify that this is a post request, like so. So there we have our request from the client to the server to create the attestation, passing in the credential that was created via the browser navigator within the request body. What we're then going to do is we're going to say if the response is not okay, then we're going to throw a new error. And this time we're just going to say that we failed to create the attestation. However, if the response is successful, then what we're going to do is we are going to redirect to the return URL. So what we're going to do is we're going to say window.location.assign, and then we're going to pass in the return URL like so. So this is the logic that resides in the client-side JavaScript. In order to create the attestation, you create the public key credential. Basically, what we're doing here is we are preventing the default form submission. We're then reading in the data from the form, the username and the return URL in this case. We're then sending the username in a request to create attestation options. We're checking to see if the response is okay. If the response is okay, then we are deserializing that JSON response into this public key variable. We're then converting the data within that public key from backend format into front-end format using the coerce to array buffer helper from the FIDO2.net library. We are then using that public key, passing that in to the credential create options for the navigator.credentials.create function. And that will then return us a credential. And we're then using that credential to send a request to the create attestation endpoint. Again, coercing several of the properties to base 64 URL format, converting from front-end format into back-end format for the JSON serialization. And if that response comes back successful, we can assume that the user has been registered and that they have been signed in, and so we can then redirect the user back to the return URL. So what we're going to want to do now is to scaffold the account register page. So what we are going to do is we're going to open up the terminal like so. We're going to cd into the web application project. And first of all, we are going to add the Microsoft Entity Framework Core Tools package. So in order to do that, I am going to paste in this command like so to say .NET add package Microsoft Entity Framework Core Tools. That will grab that package and add it into the CS proj file like so. And the next package that we are going to want is the Microsoft Visual Studio Web Code Generation Design package. So what I'm going to do is say .NET add package Microsoft Visual Studio Web Code Generation Design. And once again, that's going to add that package into our CS proj file like so. And now what I'm going to do is install the .NET ASP.NET Code Generator tool globally. So in order to do that, I'm going to run the command .NET tool install -g to indicate global, and it's going to be .NET ASP.NET Code Generator. As you can see there, I've already got that tool installed, but when you run that on your machine, if you don't have it installed, then that will install the code generator tool globally. And last but not least, we're now going to use the code generator to scaffold the account register page. So in order to do that, we are going to run the following command. .NET ASP.NET Code Generator identity. We're then going to say -DC, and we're going to specify our application DB context class. And then we're going to specify -FI, and we're going to say that we're going to scaffold the account.register page. So if we run that command, it's going to build the project like so. It's then going to run the identity generator. And what we should notice, if we expand the areas folder within identity and pages, we now have this account folder and we have our register page like so. So what we're now going to do is we're going to update that register page to make it passwordless. So first things first, we're going to start off with the code behind, like so. And what we're going to do is we're going to replace much of this code because it's no longer necessary for our passwordless register flow. I'll just convert that to a file scoped namespace like so. And then what we're going to do is we're going to get rid of most of this body like so. We can then get rid of these using statements except for the page model. And now what we're going to want to do is we're going to want to inject the sign-in manager into our register model. So to do that, we can specify sign-in manager of type application user, sign-in manager like so. And then what we're going to do is we're going to create a property here for the return URL. And we're also going to create a property for the external logins. So this is going to be a list of type authentication scheme, like so. We're going to call that external logins. And then what we're going to do is we're going to create a simple onGetAsync method for when the page is rendered using a GET request. In other words, when the user navigates to the register page in the browser. So what we're going to do is we're going to say public async task. We're then going to say onGetAsync, and we're going to pass in the return URL as a nullable argument or parameter for this method. And within this method, we're going to say return URL equals return URL, or if the return URL is null, then we're going to default that to just the root URL for the web application. Next up, we're going to specify external logins equals, and then we're going to say await sign-in manager dot get external authentication schemes async, and then we're going to convert that to a list like so. So that there is the code behind for our register page. And now what we're going to do is update the CS HTML content for the register page. So what we will do within the CS HTML file for the register page, we're going to first of all remove references to ASP root return URL from the register form, like so. We're then going to remove the validation summaries because we're no longer going to be posting this form to a post handler within the code behind Razor page. We are instead going to be using the JavaScript logic that we defined in the register file that we created shortly ago. So we can get rid of that validation summary. We can also get rid of the validation spans from each of the fields. And because this is going to be a passwordless register flow, we can get rid of the password and confirm password inputs, like so. And then we are going to want to update the email input. And what I am going to do for this is I'm going to rename email to a username for the purposes of this sample. Feel free to keep it as email or to name it whatever you deem appropriate for your particular requirements. We can then change this ASP4 attribute, and instead of that, we are going to say input ID equals, and we're going to say register username, like so. And we're then going to give it a name of a username. And we're going to change the ARIA required equals true to simply required, like so. And then what I'm going to do is change the ASP4 attribute on the label to simply be 4, and then register username, like so. Next up, I'm going to create a hidden input for the return URL. This is so that we can read the return URL as part of the form data within our client-side JavaScript file that we created earlier. So what I'm going to do beneath this div is create an input like so. It's going to be a type hidden, and this input is going to have an ID of register return URL like so. It's going to have a name of just a return URL, and then the value for this hidden input is going to be at model.returnURL, and that's going to persist that return URL from the Razor page code behind model into that hidden input, which means it will then be submitted along with the username when the form is submitted by the user. So what we can now do is we can scroll down to the bottom of the file, and within the scripts section, we can remove the validation scripts partial because we're no longer doing that client-side validation using the Razor pages logic. And instead of that, what we're going to do is we are going to render a script here, and we're going to say script source equals, and then we're going to say /js/helpers.js. And then we're going to say ASP-append version equals true in order to have the version appended onto the URL for the script. And then we're going to do the same thing, but instead of the helpers script file, we're going to reference the register script file like so. And that there is both the code behind for the register page and also the CS/HTML for the register page itself, modified to remove the password option and instead make the register experience passwordless. So now what we can do that we have all of that put together is we can now build and run the application. So what I am going to do is up here in the top right hand corner, I'm going to select debug web application. And what we can see there is it's going to build the application like so. And if I now open up the browser and if I now refresh this page, we can see that I am on the home page for the web application. So what I'm going to do is I'm going to click on the register link, and as we can see here, we are now redirected to the register page, and you can see instead of being prompted for an email and password, I am simply just prompted for username. So what I'm going to do is I'm going to enter my email address there as the username. And for the purposes of this sample, I'm going to open up the network tab like so, and then we're going to be able to see those network requests from the front end to the back end. So what I'm going to do is I'm going to hit the register button like so. And as we can see here, we are prompted to create a passkey for localhost. Now what I am going to do here is I'm going to select use a different phone, tablet or security key. And what I'm going to do now with my mobile device is I'm going to open up the camera and I'm going to scan that QR code. What I'm then going to do is I'm going to select the use passkey prompt, and I'm then going to follow the steps on my mobile device to create a passkey for localhost. And as we can see there, I have just successfully created a passkey on my mobile device, and I've been successfully redirected from the register page back to the home page. And as we can see here, it says hello tnc1997@outlook.com, which is the username that I used to register my account. So if we take a look over here in the network tab in the dev tools, we can see the first request here to create attestation options. You can see that we passed in the username like so. And then this returned the attestation options from the backend. We then used those attestation options to open up the browser UI, which prompted us to create a passkey using, in my case, my mobile device. Once this passkey had been created, we then called the create attestation endpoint within the backend. And as we can see here, we passed in our credential in the body. We can see here that we have the extensions credprops. We can see that we also have the ID and raw ID for the credential. And we can see we have the attestation object, the client data JSON, and also the transports for the response. So this credential is then passed into the backend, and we then use that credential along with the attestation options that we retrieve from the session to then create the public key credential in the backend. We then create a new application user. We attach the public key credential to that application user. We then create that user using the user manager, and we then sign the user in using the sign in manager. And all of that happens with just a username and without any password. So that enables us to use biometrics. For example, in my case, I used my fingerprint or thumbprint on my mobile device to create that passkey for the public key credential. But if you have a Windows device, for example, then you could use a Windows Hello, which might involve a PIN, or it could involve facial recognition using a Windows Hello compatible webcam, for example. If you've got an iOS device, for example, an iPhone, then you could also use things like Face ID as well as Touch ID in order to create that public key credential. So passkeys and indeed the biometric credentials are much more secure, as you can imagine, than a password, and it enables you to register for an account within ASP.NET Core Identity using just a username and then that biometric data rather than a username and a password, which is the more traditional but less secure approach. If I now minimize that and come back in here to the IDE, if I open up the database tab over here on the right, and if I open up the ASP.NET users table, we can see there that we have the user with my username created, and we also have our FIDO2 public key credential created that is associated with that particular user. So in this video, I've shown you how you can create a passwordless register journey within ASP.NET Core Identity and how you can use biometric public key credentials, for example, passkeys, instead of a password in order to register for an account and in order to have a more secure account access using a username and a public key credential instead of a less secure username and password. So I hope you found this video useful. Thank you very much for watching, and I'll see you next time.